All right, everybody. We're going to take a look at a couple of examples here. So I just had you work through the hexagon task, and hopefully you thought about at least a couple of different solutions that our strategy students might use to solve that. So I'm going to just kind of quickly talk through this process of um, first anticipating, then selecting, sequencing, and connecting. So when we anticipate, the first thing is sitting down and just thinking about all the different strategies students might use, not just the ones you've seen them use in the past, but what others might they use, in addition to what are some of the common misconceptions that you're a little concerned about. Um, this is one of those things that gets a lot easier the longer you've been teaching because you've seen a lot of different strategies that students might use. So just for some examples, the first three I'm going to share with you are going to be kind of starting with the geometry of the hexagons. So in this case, the student sees the trains as the tops and bottoms of the trains and then the two ends separately. So their equation they come up with is 4x plus 2. So 4 times the number of hexagons plus the 2 end hexagons there. The next one is the student sees the trains as two hexagons on each end, and then the ones in between, in which case there's 4 units on the in-between ones and then 5 units on the two end ones. So the difference there is the top one counted the entire top and bottom, and then just the two ends here, we're keeping those hexagons as separate on the ends. So that's another solution students might do. And in this case, the equation, as you can see there, would be 4 times the quantity x minus 2 plus 10. Another one might be counting everything and then subtracting off the things that don't need to be included. So in this case, it's multiplied by 6 because every hexagon has 6 sides, and then subtracts off the vertical sides on each of those trains, with the exception of the last 2. So there's 2 different variations shown there. A student might think very arithmetically, not really pay attention to the geometry, in which case they might just create a big table there and then look at the common differences, and the common differences being plus 4, and then talk about it recursively, maybe not give an explicit formula, but talk about a recursive strategy or a recursive formula that I can add for each time. And then finally might be somebody who then creates that same table but goes a step further and recognizes that plus 4 as being a constant rate of change, and uses that to then come up with an equation here, a linear equation using y equals mx plus b. So they can move, if they can see how things are moving forward, they can then extrapolate backwards to get that b being a 2. So in this case, it'd be y equals 4x plus 2. So here's just some, the first thinking about what students might do, a nice set of anticipations. Like I said, in addition to that, you want to be thinking about what common misconceptions might you have. So students might need to think about what perimeter is. They might not be thinking about that correctly, so you need to watch for that as you're going around. Students might assume the relationship is proportional and just kind of double it or whatever at the end, which is not uncommon. They might create an incorrect formula based on the recursion. So they identified the change as plus 4 and use that as the plus 4 for the y-intercept instead of the constant change being plus 4, meaning that that's the slope. So it might be a misinterpretation there. And the last one is they might come up with the correct formula, but there's no connection back to the geometry, and that's really important for the goals of this particular lesson. So those are things to watch out for there. So with all of that in mind, so that's the thinking I would have done during my planning. Okay, so during my planning, I would have thought about all the possible strategies that I think students might use, and the things that I would be wanting to make sure I watch for because they are common either misconceptions or maybe like the last one's not necessarily a misconception, but they're not taking it to the place that I want them to take it, which is so important for this lesson. So then when we think about selecting and sequencing, since I've planned for that, now I want to think about, okay, as I'm monitoring my student work, what do I need to pay attention to? And for that, I need to have my learning goals in mind and then consider a few things. So the learning goals for the teacher that was using this particular task are on the left there. So their goal was that students would understand that an equation can describe the relationship between two quantities, that linear relationships have a constant rate of change between the quantities. They're depicted graphically by a line and can be written symbolically as y equals mx plus b, where m is the constant rate of change or the slope of the line, and b is the value of the y quantity when x is 0, or what we call the y-intercept. That different but equivalent equations can represent the same situation. That one's really important. And that connections can be made between tables, graphs, and equations and context. Context being that geometrical representation there of the hexagons. So as I'm thinking about, I'm still in planning mode here. So of the five solution paths that I'm anticipating students might do, I want to already have a plan in my mind. Which ones would I select for students to share? And in what order would I put them? And what connections do I want to make? Those are things that I want to be thinking about ahead of time. Now, students might come up with something else, in which case at that point I need to go, okay, wait a second. I need to adjust this and maybe add in I'll have another category there for another solution. And is it one I want to pull in? Of those five, depending on how many students are working independently or how many groups I'm going to have a lot of them that are doing the same ones. Which one do I select? And as I'm thinking about that, I might want to think about those that help me highlight those misconceptions that I thought about, so we can talk about those as a class. I also want to think about whose voice hasn't been heard recently, whose voice really needs to be heard today, because sometimes just the context of what's going on in the room on that day, you can tell that somebody could really benefit from getting some positive reinforcement in front of the classroom. So a lot of that is really important to keep track of as you're going forward. So if we think about, those are the solutions there again. If I think about my goals, so if I want to meet my goals A and B, which are that an equation describes the relationship between quantities and that linear relationships have a constant rate of change between quantities and can be written as y equals mx plus b, I need to choose at least one solution that has to focus on the equation. I also need to meet goal A, which again is that equations can describe this relationship. I need to have a discussion of the solutions that connect the quantities in the hexagon to the independent and dependent variables. To meet goal B, I need at least one equation that's focused on where the solution is written in slope-intercept form, because if my goal is that they recognize that it is a line and it can be written symbolically as y equals mx plus b, then I need one of those for us to talk about. If one of my learning goals is that different equivalent equations can represent the same situation, I need to have at least two, ideally three, different but equivalent equations for us to see that they are all representing the same thing. And then if my goal is that connections can be made between tables, graphs, equations, and contexts, I need to make sure that that table that the students used in solution D and E here, we didn't show it, but we have a discussion about that table and how that connects to the hexagons. So those are things for me to think about as I'm deciding which ones I'm going to use and how I'm going to put them in order. So as you read in the article, a monitoring chart is really helpful. I have a clipboard that I always carry around. Sometimes now I use my iPad. But while I thought about all those, I just give them a quick name so I don't have all the work showing on there. So that's my strategy here. I just kind of name these. I might have a picture drawn there, just something really quickly so I can very quickly jot down which group or which individuals are working on which strategies. So when I decide when I know which one of these I want to select, I can pick who it is and I can think about who hasn't had a chance to speak recently and making sure I'm sharing that voice in the classroom. And then my order, I would write on the column there. That means the sequence of how I'm going to have them shared. So personally, I like to do this ahead of time with my order pre-selected. However, knowing I might change it depending on what other categories show up here. So that's something I always think about. And then you need to think about what time you have left in your class period. How many of these do you want to get up? So if you have time, you might want to do all of these and move from one to the next because they all have value there for making connections. However, if I don't have time for that, and again, when I say all of these, that means one of each type, not every student in the class. Because if you've got 25 students in your class, you don't need 3 examples of that, the same thing. You pick one of that particular thing. If I don't have enough time, I might just choose these 3. So I've got 2 different ways of looking at the hexagons themselves, how the geometry is related to the equation. They're equivalent but different. And then I've got the final one here, which had the table and the linear equation, which allows me to make that connection to the algebra. And it allows me to have a discussion about how recursion could have led to creating that. So through my questioning, I can connect this I can connect that table of values with the recursive strategy to this particular one, even though we didn't get up and share it. We can still bring it up in the conversation. So this is a very easy way to just kind of keep track of things and have things ready to go for your discussion. So a few other considerations, and this has been, I forgot to reference who this list came from, but I think it came from Smith and Stein in 2011, and that's part of their big book on the 5 practices. But things to think about. It's really helpful to present strategies in a sequence from concrete to abstract. That allows for the broad student access first, because if it's concrete, it's focused on the physical hexagons in this place, so everybody can point to them, can count them up, and it's very concrete and allows everybody in the class to have access to that. And then move to the more unique or mathematically complex solutions. And sequence those really intentionally. Sequence solutions in ways that highlight the connections among them and build common mathematical features. So you'll notice in what we talked about before, moving from the concrete to the last one, which somebody who just jumped right to the equation, gave access to those that needed to see the pictures and maybe only had recursive formulas and allowed us to get to the end to the other formula, but so importantly, connecting it back to the context as well. So taking that most abstract one and connecting it to the most concrete one is really important. All right, so we are going to move on to the next page and where you are going to give this a shot. Have fun.